It's morning in Toronto. And this is the kitchen at the Alias R&D and training facility. The people gathered here are the people who know Alias best: designers, engineers, and animators from some of the world's leading corporations. They use Alias to create everything from automobiles to amazing special effects for Hollywood motion pictures. We brought them together to show you how Alias works. You'll see how they use Alias modeling, rendering, animation, and peripheral tools to create, refine, and present real-world products. Some of the people you will meet are Jan Carlson, concept engineer for the Volvo Motor Company; Jay Riddle, animation supervisor for LucasFilm's Industrial Light and Magic; Judy Riley, manager of design for Timex, the world's largest manufacturer of watches; and Brooks Markert, package design engineer for Risdon Corporation, the leading supplier of packaging to the cosmetic industry.
When I got on the Alias system, it's like, whoa, because I can work on all 4 windows simultaneously.
One of the reasons that Alias is so easy to use is its clear and consistent user interface. Alias windows can be customized. They can be resized, reshaped, and placed in any position, giving you the opportunity to see your model in multiple views at the same time. A handheld mouse is the link to the interactive environment of Alias. The menu bar at the bottom of the screen is where you select your tools. Whatever stage of the design process you're working on, these buttons have consistent use and meaning, making Alias fast to learn and easy to use. When a menu button is selected, pop-up boxes appear, giving you a group of related tools to choose from. You also have access to option boxes, which enable you to adapt Alias tools to suit your needs. With Alias, you build accurate 3D models in real time as you design. To start, you choose from a variety of spline curves, from polylines to B-splines. We'll use a B-spline to create a basic curve. As you click on the screen with the mouse, the curve is created. To refine the shape of the curve, you select one or more of the points that define it. You simply move these points, called CVs or control vertices, and place them precisely where you want them. The ease with which you build accurate 3D models is the true power of Alias. And who better to demonstrate the Alias modeler than the people who use it every day? They have literally hundreds of powerful modeling tools to choose from. We'll focus on some of the most commonly used surface creation and detailing tools, like boundary patches, to create surfaces by defining 3 or 4 boundary curves; trimming to cut holes in and intersect 3D surfaces; extrusion to create tubular objects; revolution to create precise swept surfaces; and skinning to create surfaces between cross-sectional curves.
Goodyear has done a specific tread for Volvo.
That's true. We have. We've got, I think we've got a couple of projects going with you right now.
Ed Covert is a design engineer for the Goodyear Tire and Rubber Company. North America's largest manufacturer of tires uses Alias to model the tires of tomorrow.
One of the key features that we found in Alias is being able to merge traditional design methods with the electronic media. As you see here, we've got a tread sketch that we've scanned in via the Haltech scanner, and it becomes the basis for what we can use in developing true 3D geometry.
Using a B-spline curve, Ed creates the contours of the tread pattern by tracing over the background picture. The same concept can be used to create a 3D model from existing blueprints.
We can begin to duplicate these elements very quickly and conveniently, and through our transform function, using non-proportional scaling, we can begin to distort those in a couple of different directions, which often arrive at new and different ideas than might have originally been planned.
Now Ed moves to a side view and uses the patch feature to create the depth of the tread.
We're going to build surfaces, and we're going to do a patch, and we're going to select those elements. in the second element, and the system is going to generate a patch between the top surface and the bottom surface, which is going to act as the sides or the perimeter around each tread element.
When the tread concept is complete, the cavity of the tire is created using surface of revolution. Ed has created a cross-section profile curve for the tire cavity.
We're going to go into build surfaces and revolve, and we're going to select, say, a 45-degree section rather than going a full 360.
Here, the surface is revolved 45 degrees to create the tire cavity section.
We very quickly went from a flat two-dimensional piece of geometry to a three-dimensional piece of geometry.
With the two primary components of the project now constructed, Ed uses Alias trim surfaces to blend the two surfaces together. Trim surfaces offers a number of trimming operations. Ed chooses intersect, joining the tread to the tire cavity. He can then trim away the excess surface, fitting the components together seamlessly. With the intersection complete, Ed selects which surfaces he wants to keep and which to trim. Now he'll use Quick Render to evaluate the new surface. With Quick Render, Goodyear sees surface details as they're created. As the concept is developed further, higher quality renderings are generated.
You can see the fine detail in the geometry, the undulations in the sidewall, and allows us to get a good visual impression of what has happened in that geometry.
When the concept has been finalized, photorealistic renderings speed the decision-making process and more.
We were not simply left with an interesting-looking image or a very fine quality rendering, but an actual engineering database that can be transferred and used for production.
Goodyear also makes use of a powerful new medium for evaluating a three-dimensional design, stereolithography.
This particular part is the first tire worldwide that's been developed in Alias and translated to SLA, and as you can see, this is the actual finished tire that concept was from.
From the original sketch to the finished product, Alias speeds the design process at Goodyear. For British Telecom's Mike Lawson, accurate and reliable data transfer is critical. British Telecom outputs the Alias 3D database for prototyping and manufacturing and brings existing products into Alias for restyling.
What we have on the screen here is two sets of surfaces. The top one is a collection of surfaces brought in from Duct, which is our engineering surface modeling system. The bottom one is a restyling. What we've done is read the surfaces into Alias through IGIS in order to remodel and restyle the ear cap depression and the mouthpiece depression. We can take the data from Alias into Duct and use that for mold flow analysis and stress analysis on the plastic molding.
Here's how British Telecom used Alias to restyle the ear cap depression for next year's product. First, Mike creates the cross-section curve. Then, using surface of revolution, he revolves the curve, creating the 3D geometry of the depression. Then he rotates the part and moves it into position, preparing to use Alias trim surfaces to sculpt out the area he wants to cut away. With Alias, positioning is visual and precise, using either keyboard or the mouse.
What I want to do now is trim a hole in the handset and trim the depression back to meet that handset.
Using Alias trim surfaces to intersect the surfaces, Mike can select the area he wants to keep and the excess he wants to trim away. When the process is complete, Mike uses Quick Render to evaluate his work. Now that the phone is finished, Mike will model a new chord.
I found a very simple way of doing it, using the extrusion process on Alias. First of all, I picked up a circle primitive and positioned that right in the middle of the screen, and now turned on the CV magnet, which snaps each new control point to an existing one. I'm using it to snap around the circle.
Once Mike has extended the curve around the circle a number of times in one plane, he'll use another Alias feature, proportional modification, to stretch it out.
The proportional modification command enables me to get hold of one point but modify all the other points relating to it.
To create the surface of the cable, Mike uses the Alias extrusion function. On the lower left side of the screen, he's created a cross-section to give dimension to the cable.
What I do is I extrude the cross-section of the curly cable along that spiral path. I select the cross-section, I select the spiral, then it extrudes that cross-section along the length of the spiral.
Once the surface has been created, Alias Quick Render shows Mike his next product fully shaded in seconds.
We're into both the visualization and the realization of the product. At a very early stage, we want to give people the feeling that that product's there, give them a feel of the reality of the product 6 weeks into the design program, not 12 months.
At British Telecom, Alias is effective communication. The same holds true for the Volvo Motor Company. Packaging engineer Jan Carlson is based in California, while designer Doug Fraser works at the head office in Gothenburg, Sweden. Alias has been vital for Jan and Doug to work effectively as members of a design team that is spread across the globe.
The way we are transferring data from California to Sweden is via modem.
I understand that Volvo as well has been doing a lot of work using CATIA.
We have established some very good working communication between Alias and CATIA's milling toolpath program. We're creating a lot of milled models in between Alias and CATIA.
Here we see Doug and Jan working together, using Alias to create a new car concept for Volvo.
I got information from from marketing about the length, width, and heights and wheelbases and so on. I just made this concept layout, and I just want to put the rear mannequin into position.
With Alias, you can move and rotate individual components or groups of components in 3D and see the results as you work.
Now the mannequin is in the right position, and I think you can go ahead and create the exterior around this, and then we communicate and see what we have to change.
The designer takes the input from the packaging engineer and moves to the next phase of the design process, the creation of the surfaces that will give form and shape to the vehicle. Doug has created the basic boundary curves that define the edges of the roof and front windshield. Alias boundary patches are a simple way for Doug to create a surface using any 3 or 4 curves that define the outer edges of the surface. When he has finished selecting the curves, the surface is automatically created.
And let me now begin to go through the process of getting this surface in such a state that I can easily manipulate its characteristics. So the first thing I would do is start to blend these various patches together. It asks me to pick the components I want to attach. I pick the hole that's extending off of the first surface I want to attach, and then I pick the hole of the second surface.
The blending is now complete. 3 surfaces become one, making it possible to manipulate and fine-tune the entire surface as a unit.
And now I want to start to manipulate these CVs in such a way that I can pull that corner forward. This will have very positive effects in the wind tunnel.
When the roof line is precisely what Doug is looking for, he uses Alias Quick Shade to evaluate the surfaces he has created. When he has completed this iteration, the data can be transferred back to Jan for further engineering input or sent to CATIA to produce a milled model for evaluation. Another way the Volvo design team can evaluate the full model is with Alias animation. Here, they can accurately simulate point of view or the movement of the car. Like automobiles, watches are statements of style and precision. At Timex, the world's largest manufacturer of watches, modeling with Alias is where the design process begins. They use surface of revolution to create circular surfaces, trim surfaces for precise detail, and text, a library of existing characters to expedite the process of adding letters and numbers to models. This accurate 3D database is now ready to come to life with Alias rendering. Timex design manager Judy Riley.
Well, for watches, rendering is really everything because we don't have the possibility of doing foam core mock-ups or clay models of anything because watches are so small and precise that you can't reproduce it with a medium like clay. You have to, the prototype has to be very precise. But for the industrial designers, our medium for communication is rendering. And of course, traditionally we did that with sketches, and now we're doing it with Alias. And it gives us so much more flexibility for making modifications. Once I get an idea sort of down on thumbnail sketches, you know, using whatever inspiration I need from the fashion industry or from, you know, from other types of products. I then go to the Alias system with my thumbnails in front of me and work from that.
Judy uses Alias Quick Render as a tool to quickly visualize her designs with color highlights and textures.
So now I just quick rendered that. I have a good idea now of how my image is going to look when I do a final rendering. You can tell where the lights are and the features of sort of each surface.
When test renderings with Quick Render have been completed, final high-resolution Alias images give Timex management a realistic model of the proposed design faster than ever before, making it easier to make next year's product decisions.
So now I think that we tend to fine-tune things and get it right the first time.
You don't have to be a Fortune 500 company to benefit from Alias. Neil Owen is a product designer for Sundberg-Ferrar, an independent design firm.
At Sundberg-Ferrar, since we are a consulting firm, we're always looking for new business. And Alias has been a tremendous PR tool for us, simply because clients have heard that we have it, and they've been coming in just for demos and seeing what we can do with it, and nobody's left there unimpressed.
Yeah, it's certainly been a great tool for us internally as well. We have a lot of people at Industrial Light and Magic who don't necessarily understand the process of computer graphics. And with Alias, we're able to show them very quickly the whole process. So, Neil, what is that thing you have there?
This is the Trip Master. This is something that we at Sundberg-Ferrar did for Rockwell. And what it basically does, it keeps track of the trucker and his trailer, the gas mileage.
Effective presentation of new product designs is important for independent design firms like Sundberg-Ferrar. Alias Design Paint is a full-featured electronic paint system, perfect for creating realistic textures, lifelike backgrounds, or adding finishing touches. Here, Neil is retrieving a scanned-in photograph to create a setting for the model he built earlier. As he turns off the mask he created, the Trip Master is automatically composited into the photograph. Another easy way to create a background for the design is to specify a color ramp. This color palette menu gives Neil over 16 million colors to choose from. Once he has selected the color mix, he can apply it to the background in one easy step. With Alias Design Paint, you have full control over your paintbrush, creating effects such as chalk, pencil, crayon, and spray paint. Here we see Neil modifying the shape of a brush. Now he uses Design Paint to adjust the color of the Rockwell logo on the Trip Master. He selects the position, displays the file, applies the new darker gray color, and removes the mask. It's that simple. Now Neil returns to the modeler to use Alias texture mapping to apply the new Rockwell label to his 3D model. He can specify the size of the label, how sharp or blurred the detail will be, and place the label exactly where he wants it. With all the elements in place, Neil completes his final rendering.
Everything's nice and sharp, and you can see all the details. The Rockwell logo, we can see the key panels and how all the text works on there. Also the aluminum, how the highlight works with that, and the bottom control panels. Also we can see the highlights in the plastic in the bottom, the strain relief, and the cord. Once you finally see the finished model, this is what it looks like.
Alias wireframe animation can be set up quickly and easily for real-time viewing to communicate exactly how the product is assembled.
That's the real beauty of this design, is the way everything fits together.
Package design engineer Brooks Marker understands the real value of powerful presentation.
Presentation in our industry is very important. The cosmetic industry, our customers are really concerned about the aesthetics. And traditionally, we've communicated through orthographic blueprints. And a lot of the marketing design people have no idea what they're looking at. One of the primary reasons that we chose Alias is for its realistic rendering capabilities.
Here Brooks is completing a package model for a Cheeseboro Ponds product. He's using Alias Quick Render to visualize the surfaces of his design.
We can immediately see that the bottle's not supposed to be a blue. I want to change it to this purple color here.
With Alias, you control color with the surface spreadsheet.
The thing I really like most about the surface menu is that it's intuitive.
The surface spreadsheet gives Brooks a palette of over 16 million colors to select from. He can change his colors by using the RGB or HSV mixing cells, creating tints or shades from his base color. And with the interpolation scales, he can pick from a blend of any two colors. By adjusting characteristics like shininess, specularity, and transparency, he can create any surface type, from rubber to chrome to glass. When the final surface characteristics are selected, Brooks turns on Alias Quick Shade.
This is Quick Shade, and it allows me to manipulate the geometry fully rendered in real time and evaluate the surface characteristics.
Not only can Brooks move the object, he can keep the bottle in a stationary position and move the lights to check reflections and highlights. When the surface characteristics have been selected, the model is fully rendered using the Alias Raycaster. Raycasting makes it possible to have realistic shadows and reflections in the scene. For the ultimate in photographic quality rendering, Brooks uses Alias Ray Tracing, which can accurately show reflection and refractions in the glass.
This is just phenomenal. The difference is just incredible. You can see all the internal reflections. You're getting the liquid level in here, the wall thickness of the glass, the reflection of the bottle onto this pedestal, the reflection of the glass onto the metallic cap, reflection of the background onto this metallic plate, and you basically have photorealism.
The excitement that Alias animation brings to design has made Alias an important tool for Hollywood as well. LucasFilm's Industrial Light and Magic uses Alias to produce special effects for television and major motion pictures. Computer graphics supervisor Jay Riddle explains the process.
You know, I've heard a lot of people here, fascinating, talking about their actual use of Alias in designing of real products. And in our design, the concept itself is really the product. I'm going to show you a storyboard here, which is sort of the first step in visualizing, for us, an animation. This is from The Abyss, and in this film, we created about 75 seconds of animation.
The same basic tools that industrial designers use to present their products are the starting point for animation at Industrial Light and Magic. Here Jay uses Alias to create the backbone for the pseudopod, the underwater creature from the abyss.
Okay, now the next thing that's involved here, once we've got a spline curve, is animating the control vertices over time.
To choreograph the motion, Jay creates a column for each point on the curve that he wants to move. The columns are automatically inserted into the dope sheet, an easy-to-understand visual display where all the details of the scene are laid out.
The dope sheet gives you places to put columns of objects or CVs that can be animated in this direction versus time. These are frame numbers in the vertical direction. Now we're going to actually assign some keyframes to the animation. Let's set this to be frame 1. Okay, now we'll move our CVs a little bit. To do that, we just go in and pick the CV that we want to move and place it where we want it to be in the next keyframe position. Now let's go set that to be a keyframe. In this case, we'll choose frame 30.
Jay repeats this operation until all keyframes have been selected and placed in the dope sheet.
Now we can actually play that animation back. And you can see here the pseudopod sort of lifting its head up and pulling itself forward a bit.
To fine-tune the movement, Jay uses Alias parameter curves. Parameter curves give you full control over the speed of motion and position of elements over time. After creating the basic movement of the pseudopod, ILM transferred the Alias database to their own proprietary system for further modification, and then back into Alias for final visualization.
Some of the other shots that were necessary for the film required the pseudopod head to transform from a smooth shape into that of one of the actors' faces. What I have brought up on the screen here is a representation of some three-dimensional data from a 3D digitizing process. We used Alias for visualizing this in the quick shade mode, and we can actually move the head around and examine it from different views.
With the head now complete, Jay attaches it to the body of the pseudopod. It's now time to give the creature realistic features and bring it to life. This is accomplished with a cubic environment map, a six-sided panoramic view of the setting that the pseudopod will be in.
The cubic environment map was actually created by photographing different views in the actual set in South Carolina. Here you're seeing a background that's being refracted through the object. You're seeing the reflection of the cubic environment map on the object, and again, specular highlights, the little white highlights here from the lights in the set.
The cubic environment map and the pseudopod model were composited into the final film by ILM with spectacular results.
It's trying to communicate.
For the creation of lifelike illusions or the presentation of new products, Alias animation is the highest level of visual communication available in the world today.
So real. I can't believe it's so real.
From special effects to automobiles, you've seen how designers, engineers, and animators use Alias to create, refine, and present real-world products. With Alias, data transfer is accurate and reliable, whether you integrate existing data or output your designs for evaluation, manufacturing, or